Hello everyone, we've got a 5-mark question here which involves some differentiation, and this is for IGCSE and it's question 20 from 2023, paper 1 I think. So it says the radius of a right circular cylinder is x. Okay, I've just drawn a right circular cone there because what it means when they say right circular is it means that the vertex of that cone lies directly above the center there. And the same kind of idea for a right cylinder. So the center of that circle lies directly above that one. So they're just basically saying that that's a 90-degree angle. It's not at some kind of weird angle. So the height is 800 over pi x minus x, and the volume is v. So first of all, it says we've got to find the maximum value of the volume. So let's write down an expression for the volume. So the volume of a cylinder is the area of the cross section, which is going to be pi x squared in this case, because we're told that the radius is x, times by the height, which we know we're also told is 800 over pi x minus x. So let's expand that bracket now. So we're going to expand the bracket. So we have pi x squared 800 over pi x. So the pi's cancel, one of the x's cancel, giving us 800x. And then here we have pi x squared times x is minus pi x cubed. So that's our expression for our volume. Now we've got to find the maximum volume, okay? So they're expecting us to remember that the maximum is given when we differentiate our expression and set it equal to 0 for a turning point, okay? So we need to differentiate this expression that we've just got and set it equal to 0. So 800x will differentiate to 800. Pi times x cubed will go to 3 pi x squared. We're going to set it equal to 0 for the turning point. Then we're going to add the 3 pi x squared over to the other side, divide by 3 pi and square root. And that gives us that x is 9.213 centimeters. Now that's not the final answer. That's the value of x that gives us the maximum value of the volume. But we're asked to actually find the maximum value of the volume. So what we need to do is we need to take our 9.213 and sub it into our volume equation that we've just found. So 800x minus pi x cubed, this equation, but with x as 9.213. And when we sub that in, we find out that we get a volume of 4914. So 4914 centimeters cubed is the volume of the maximum volume of the cylinder. I hope you found that helpful, and I will see you in the next video.